Hello, today we're going to talk about some applications of normal distributions. So far, we have looked at the standard normal distribution, which is a normal curve with a mean of 0 and a standard deviation of 1. So we can use our calculations in order to find areas, in order to find z-scores, the same way with a normal distribution that is not a standard normal distribution, meaning we don't have a mean of 0 and we don't have a standard deviation of 1. So most real-life situations are not standardized to a standard normal distribution. So what we would do in that example, we would use our conversion formula from before. And the conversion formula to convert a score to a z-score is we take our value, we subtract the mean, and divide by the standard deviation. And then we always round z to 2 decimal places. Okay, so in essence, we're taking our non-standard normal distribution and we're going to apply this conversion formula. So the z is equal to x minus mu divided by sigma, and we're going to change it to a standard normal distribution. Okay, so let's look at an example in how we can do that. All right, so here's our example. It says Tall Clubs International. Tall Clubs International has a requirement that women must be at least 70 inches tall. Given that women have normally distributed heights with a mean of 63.8 inches and a standard deviation of 2.6 inches, find the percentage of women who satisfy that height requirement. Okay. Well, what do we do? Our first step is always to sketch a normal curve, to label the mean and the x value of interest. Then we're going to shade the region representing our desired probability. For each relevant x value, we're going to convert it to a z-score, and then we can use computer software or we can use our table in order to find the area, which is our probability. Okay, so let's see how this calculation works. All right, so we have our normal distribution. So we have a nice normal curve. Okay, it is not a standard normal distribution. We have our mean of 63.8, so that goes right in the middle. And then we have a standard deviation of 2.6 inches. So we have a mu of 63.8 and our sigma is equal to 2.6. So here's our x values. The idea is we're going to convert this to z-scores and then we find the area. Okay, Tall Clubs International has a requirement that women must be at least 70 inches tall. So what is the percentage who are at least 70 inches? So let's put them maybe right over here. Here's 70 inches. How many of these women are at least 70 inches? So it looks like it's a very small group that actually fits this category. So let's convert our value. So we're going to use the conversion formula. So z is equal to x minus mu divided by sigma. We're going to plug in our x value. X is 63.8. Sorry. X is our 70. We're trying to convert this one because when we convert the 63.8, well, we know the new mean for our normal standard distribution is equal to 70. So we're going to plug in 70 for x. We're going to subtract the mean, 63.8. We're going to divide by the standard deviation. So let's look at our calculator over here. We have 70 minus 63.8, and that divided by 2.6 is equal, and I don't think you can see that very well, that is equal to 2.38. We always round z-scores to 2 decimals, so over here we have 2.38 is our associated z-score. Okay, so what we're trying to find is what areas to the right of this z-score. So we know we can use our table. We can locate 2.38 on the table, and that will give us the area to the left. So in order to find the area to the right, we can do 1 minus that area. But we've also used our normal CDF. And the normal CDF, we put in our lower z-score, and then we put in the upper z-score, and that will give us the area as well. So normal CDF, our lower z-score, where our area starts, is actually 2.38. Our upper z-score is a very, very large number, so let's put in 10,000 over here, and let's see what percentage fits. Okay, so to find the normal CDF, we go to second and distribution. We arrow down to normal CDF. We enter our lower z-score, which is 2.38. Then we end up put in our upper z-score, a very large number, for example 10,000, and then we hit enter twice. So this answer over here is 0.0087. So when we change this to a percentage, this is actually 0.87%. So less than 1% of the population is tall enough to be part of Tall Clubs International. Okay, so the idea over here is we draw our normal curve. We label it with the mean and then the value that we're interested in. Like over here, we're looking for the area which is for the people who are taller than 70. So we draw 70 and then shade to the right. We then convert these values to z-scores. The mean gets converted to a 0, and then the 70 changes it to a 2.38. Then we can use our table by looking at the area to the left and then subtracting that probability or that area from 1. Or in our case, we used the normal CDF. We entered our lower z-score and then the upper z-score, and that gave us 0.87% of the population. It's asking for the answer as a percentage. Now here's one more way to solve this kind of problem. And the nice thing is, if we do it this way, we don't even have to use this conversion factor, because our calculator actually has an option where we put in our lower x value, our upper x value, and then put in what our mean and what our standard deviation is. So this really simplifies the process. So instead of having the normal CDF with the 2 z-scores, I'm going to put in my lower x value, then my upper x value, and then afterwards I'm going to include my mu and my sigma. So let me show you how that works on the calculator. So again, we're going to find it under distribution over here. We're going to go to normal CDF again. We're going to this time enter in x values. So our x value was 70 for the lower one. The upper one we can leave at 10,000. Our mean is 63.8, and our standard deviation is 2.6. When we hit enter over here, we end up with 0.00854, and again, let's round it to 4 decimals. This is 0.0085. So it's very similar, which is 0.85%. Now, why do we have a slight difference? Well, first of all, over here, when we found the z-score, we rounded. So due to that rounding rule, we end up with a slightly different answer. On your homework assignments, you should be able to use the calculator in order to get the correct answer. So there's a little bit of room as far as the answers. All right, so now I want to go over a different type of question where it's in reverse. So over here we were given an X value and we were trying to find the percentage of women, which is also sometimes some of the questions would be looking for a probability or looking for an area. It's all the same. Now we're given a probability or an area or a percentage, and this time we're doing it in reverse. So let's look at the procedures for finding values from known areas or probabilities. Okay. So here is our procedure. We first sketch a normal curve, enter the given probability or percentage in the appropriate region or graph, and identify the X values being sought. Then we use technology, we use our table to find the z-score corresponding to that area. And then we use the conversion formula. Now this is basically the same conversion formula we used before for the z-score, right? Remember, the z-score is x minus mu divided by sigma. What we can do is we can multiply times sigma, and then we can add mu to both sides. So we end up with x is equal to mu plus z times sigma. So it's just elementary algebra in order to change our original formula to this form over here, where x is equal to mu plus z times sigma. Refer to the sketch of the curve to verify that the solution makes sense in the context of the graph. And that's always a good idea to check your answer, make sure that it is a reasonable answer over here. So let's look at this example over here. So this is the example of aircraft cabins. When designing aircraft cabins, what ceiling height will allow 95% of men to stand without bumping their heads? Men's heights are normally distributed with a mean of 69.5 inches and a standard deviation of 2.4 inches. First, draw the normal distribution. So over here we have our normal curve. We want 95% of the men to be able to stand, so we're shading in the area of 0.95. We know our mean of 69.5, and we know our sigma of 2.4. So we have mu is equal to 69.5, sigma is equal to 2.4. And now we're going to be able to figure out first the z-score, then the x value. So how do we find the z-score down here? Well, in order to find a z-score associated with an area, we actually use the inverse norm. Okay, and then we enter in the area on the left, which is 0.95. So let's use that over here on our calculator. So we're going to go to distribution by clicking the second vars button. Then we're going to go down to inverse norm. We put in an area which is to the left, so 0.95, and then we hit paste. Okay, this is one of the z-scores that is actually uses 3 decimals, so it's 1.645, which is the one that is down here. So a z-score of 1.645 has an area of 0.95 to the left. So we're now going to use this. We're going to plug into our formula from before, right? So x is equal to mu plus z times sigma. we're plugging in our mean of 69.5, our z-score, which we just found, of 1.645, and our standard deviation of 2.4. So let's multiply this all together. So we have 69.5 plus 1.645 times 2.54, excuse me, and that is equal to 73.448. Let's round it to 1 decimal because that was what our mean was given as well. So we have 73.4 inches. So what we did is we first drew the curve, we shaded in the area, we drew our scale with our x values as well as the scale with our z-scores. When we're converting our mean to a z-score, it becomes 0. And then when we're looking at the inverse norm, this gives us the associated z-score. We could have done the same thing from our table just by looking at the center of the table until we find the number closest to 0.95, and then finding that associated z-score. All right, so the only thing that I want to show you is there's again a function on your calculator which allows you to find this x value without having to use that conversion formula, and it's simply looking at the inverse norm again. This time we enter in our area to the left, same thing. We also enter in our mean and our standard deviation right after, and so the calculator converts this normal distribution to a standard normal distribution. So let's go to inverse norm by clicking second bars, airing down to inverse norm, putting in the area. I've already entered that. My mean is 69.5. My standard deviation is 2.4. I now hit enter, and my answer is, my x value is 73.4 inches. So you can see the answer right over there. All right. So very good. So what I want to do is go over just a couple more examples from your handout. The first one says, find the area of the shaded region. The graph depicts IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. Okay, so again, you can change these values to z-scores, and then you can find that area to the left. Or we can use the second way, the simplified option, and just using the normal CDF by entering in the value. So we want to find the area to the left of 110. So we're going to use the normal CDF, put in the lower x value, the upper x value, and then we're also entering in our mean and our standard deviation. So just to make our life a little easier. So what is the lower x? Well, the lower x value is a very small number. Okay, so let's put in negative 10,000. Our upper x value, this is where our area ends, is 110. So you always go from the left to the right. You look at where does my area start. Over here it keeps going, so we're just going to put a very negative number. And then our upper x value is where it ends. So we end up at 110. We then enter in the mean and the standard deviation in order to find the answer. So let's go back over here. We're going to go to second bars. Going down to inverse to normal CDF, our lower score, you can actually keep it at that default number, because this is a negative 1 times 10 to the negative 90 to the 99th. So it's a very negative number, so you don't have to change that. Our upper one is going to be 110. Our mean is going to be 100, and our standard deviation is going to be 15. We hit enter twice, and we end up with an area of 0.7475. And just remember that we always round this to 4 decimals. Okay? All right, so I want you to do number 12 on your own. This one is really simple because, again, you can use the normal CDF. This time you have a lower and an upper X value given. So you just plug those in, and you should be able to find the correct answer. We're going to go over one more question, and that is number 13 down here. This time we have an area given. We're trying to find an X value that's associated. So let's read the problem. In one region, the September energy consumption levels for single-family homes are found to be normally distributed with a mean of 1,050 kilowatt hours and a standard deviation of 218 kilowatt hours. Okay, so we have the mean of 1,050 and the standard deviation of 218. Find P45, which is the consumption level separating the bottom 45% from the top 55%. So remember, our first step is to draw our curve. We're going to shade in the region, so 45% is just slightly less than half. So this is my bottom 45%, which is 0.45. Okay, so the idea is, if I use the table or if I use the inverse norm, it's going to give me a z-score, and then I can convert it. But instead of doing that, I'm going to use the inverse norm. I'm going to tell my calculator the area to the left, which is 0.45. Then I'm going to look at what is my mean, which is 1,050, and what is my standard deviation. And then I let the computer do all the work. By the way, it says the bottom 45%, the top 55%. Obviously, the area to the right is 0.55. But when we're using inverse norm, we always have to use the area to the left. So very, very important over here. So let's look at this. We're going to go to second distribution, arrow down to inverse norm, put in the area to the left, which is 0.45, put in our mean, 1,050, put in our standard deviation of 218, and then hit enter twice. And that gives us an X value of 1,022.6. Now we can round this up just because our mean is given as a whole number, so this is approximately 1,023. So look at your answer and see if it's reasonable. Our mean is at 1,050. The 45th percentile is just right below the mean, and it's just slightly less. So yes, our answer is reasonable, and so we are good to go. So I want you to answer number 14 on your own. Do the same thing, use the inverse norm, look at what is the area